Section 5.3, example 7, finding the maximum number of turning points using the degree of a polynomial function. Find the maximum number of turning points of each polynomial function. So here we have a line. So there are no turning points. This is like f of x is equal to x. So I'm going to say this is degree 1. F of x is equal to x squared. That's a parabola, so we have one turning point. A cubic function that has something like this. We have one here, two turning points. A quadratic function would have 1, 2, 3 turning points. So the amount of turning points is always going to be one less than the degree. So let's take a look at part A first. So f of x is equal to x cubed. That looks like a high degree. X to the power 5. This one looks like it's winning. So x to the power 5, x to the power 2, x to the power 0. It looks like this is our leading degree. So leading degree. That's our leading term, not degree. So it's our 4x to the power 5, which means it's degree 5, or degree 5. So maximum turning points. So turning points would be 4. So here, maximum amount of turning points is going to be 1 less than the degree. So here it's going to be 4. Here we don't really have an actual degree. Let's try starting with the leading term. And to find the leading term, we really don't have to multiply everything out. What we do have to multiply is all of the degrees. So here we have x squared. So starting off with our coefficient of -1. In this first part, we have x squared. For this second part, I know I want to say 1, but we can't say that. It's going to be this one right here, 2x squared. So that's going to be -2x to the power 4. So that tells us that it's degree. So degree 4 and max amount of turning points is going to be 1 less than that, so 3. And there we go. That's a max amount of turning points for each of those functions. If you have any questions, please feel free to ask. Otherwise,